The objective of this video is to find the cross of vector product of two vectors u and v given by their components u equal ux, uy, uz, v equal vx, vy, and vz. The cross or vector products of the two vectors u and v is denoted as u cross v. It is a vector perpendicular to both vectors u and v, and whose direction may be determined using the right-hand rule shown here. In this video, we are more interested in finding the cross product u cross v when the u and v are given by their components. The way to do it is to write u cross v in terms of 3x3 determinants as follows. The first row is made up of the 3 unit vectors. The second row is made up of the components of u and then the component of v in the last row. We now express the 3x3 determinants in terms of 2x2 determinants as follows. The first determinant, the first 2x2 determinants, is made up of these terms u, y, u, z, vy, vz, and the unit vector I, minus the second determinant is made up of these terms here, ux, uz, vx, vz, and unit vector j. The third determinant is made up of the terms plus ux, uy, vx, vy, and the unit vector k. We will now look at a numerical example. So we are going to find the cross product of the vectors u equal 1, 2, negative 3, and v equal 0, negative 1, 2. We start with the 3x3 determinants. So u cross v equal the 3x3 determinants, which is I, j, k here. The component of u, 1, 2, negative 3. Then the components of v, 1, negative 0, negative 1, and 2. In terms of the 2x2 determinants, so the first determinant we said it's 2, negative 3, negative 1, 2. These terms here. I minus the 0, 1, so 0, 1, negative, so 1, 0, negative 3, 2, and then j, plus the third determinants made up of these terms here, 1, 2, 0, negative 1, and then k. Before we go any further, a reminder on how to find a 2x2 determinants a, b, c, d. This is given by a multiplied by d minus b multiplied by c. So let's go back and finish the calculation of u cross v. The first 2x2 determinants is given by 2 multiplied 2 minus 3 negative 1 I minus 1 times 2 minus 3 times 0 j plus the third 2 by 2, it's 1 multiplied by negative 1 minus 2 multiplied by 0 k. We now simplify to get I minus 2j minus k, or in component form your cross product is given by 1, negative 2, negative 1. Now let's put everything together. So we found that u cross v is a vector with component 1, negative 2, negative 1. U is a vector with component 1, 2, negative 3, and v equal 0, negative 1, 2. What we are going to do now is to check that u cross v is perpendicular to both u and v. And we will do this using the dot product. If you remember, when two vectors are perpendicular, their dot product must be 0. But let's first see what is the dot product of two vectors. So two vectors, A, B, C, dot E, F, G is given by A multiplied E plus B multiplied F plus C multiplied G. It is different from the cross product, of course. So let's now calculate the cross product U cross V dot U cross V, it's 1, negative 2, negative 1, dot U 1, 2, negative 3, 1, minus 4, plus 3, that gives 0, which means U cross V and U are perpendicular. Now let's do U cross V dot V, 1, negative 2, negative 1, dot V, which is 0, negative 1, 2. That gives 0 plus 2 minus 2, that also gives 0, and it means that V and U cross V are perpendicular, as we said at the beginning of this video. That's the end of the video.